A concept important we put on the very first page of this unit. We will refer back to this about whatever number that is times. All right. Oh, and that's factorial, so that's even bigger than you think it is. Okay. So one of the biggest concepts we need to know for this entire unit is going to be taught in the first step. Okay. Now the nice thing about this great important concept is it's very easy to understand. Okay. In fact, you already are so good with numbers, it will seem silly we're even spending time on this, but trust me, this will help later in the unit. So, on the grid to the right, draw 5 vertical lines of varying length. Draw 1 in each quadrant, and then 1 spanning 2 quadrants. So again, just draw any set of lines. It doesn't make a difference. Here's one in this quadrant. Here we have one in that quadrant. Here we have that one. Varying lengths. All right. All right. And then one covering 2 quadrants. It doesn't have to be the same as mine. Doesn't have to be. All right. So now draw, next line, write its length. So this is 4 on mine, this is 2, this is 1, 2, 3, 4, 5, 6. This is 3, this is 7. What is a quick mathematical way to calculate these lengths? Now they're vertical lines, right? So did x change? No, what's the only thing that changed? Y. So top y value minus bottom y value. And it does seem silly that we even worry about this, but we're going to be doing this a lot. All right. What can we call the width of these vertical lines? Well, they have a width, don't they?
Yes.
Dx. Right? It's a really small horizontal distance. So a really small horizontal distance. Yeah. Yes. All right. Now, repeat this process drawing horizontal lines. So 5 sets of horizontal lines. All right. Do this in blue.
EY.
I think you're going on a little ahead of us. Slow down. It'll be okay.
Wait.
I know.
That's not a D. That's anything else. We're not gonna do it. That may be PY, the opposite.
All right. So this will be 3. This will be 6. This is 5. This is 2. This is 1, 2, 6, 7, 8. 8. All right. Again, the quick way would be the right x value minus the left x. And yes, we call the width of these horizontal lines dy. Otherwise, a tiny change in y. So our incredibly complicated, extremely important fact that we just figured out is to get the length of any vertical line in the coordinate plane, it is top minus bottom. You get a horizontal line and in coordinate plane, it is right minus left. Now that's all the time we have for the day. I'm just kidding.
I'm fine with that.
We still got 30 minutes. What are you talking about?
Well, we got 3 minutes.
All right.
What they said. You heard the party? I think it's what they said.
All right. Finding area between curves. Key skill needed. How can we find the length of a segment on the coordinate plane? We kind of just figured this out, right? If length is vertical, okay, top minus bottom function. Key to this is these functions, if we're doing top minus bottom, will be in terms of f of x. Because what is y equal to? F of x. If it's the top y minus the bottom y, then it's f of x minus f of x. So,
I think we're do that's how you spell vertical.
yeah. There we go. I told you at the beginning of the year, one thing I can't spell. So if horizontal, then no, not the first time I've misspelled something today.
We thought it's double.
So right minus left. Now again, if the functions are right minus left, the function needs to be in terms of what? Yeah, f of y. Now, will we always be given the function in terms of f of y? No, sometimes we'll have to solve for that. All right. Problem 1. Find the area of the region bounded by the graphs of the curves y equals x squared. Okay, so y equals x squared, so 0, 0, 1, 1, 2, 4. One, like 2, 4. So your basic parabola. And then y equals 3. So y equals 3. Y equals x squared. Now we are trying to find the region bounded by these two functions. So that would be this area right here. All right. So shade the enclosed region, label the points of intersection. We do need the points of intersection. Yeah, so we have if x, yeah, so square root of 3, 3, negative, square root of 3, 3, and positive, square root of 3, 3.
If you just put 3 in for y, and then how do you solve? Oh,
Yeah, we know y is 3, so we just set x squared equals 3, so plus or minus 3. All right, so shade the enclosed region, label the points of intersection, and label the curves, which we've already done. That's part 1. Part 2 is to draw a respective rectangle, decide if representative rectangle should be drawn vertically or horizontally. really makes little difference. But since my function's already in terms of x, we probably want to do what? Vertical lines. Okay. So, and here's one rectangle here. Oh. All right. In this case, what's the top function? Y equals 3. Yeah, y equals 3 is the top function. What's the bottom function? Y equals x squared. Now, if we try, because again, we should be able to do this left to right as well, right? The problem is, do I have a top and bottom function or a left and right function if we do this to left and right? I don't. It's the same function. So what I have to do in that case is I would have to split it into two, or I can actually technically just double the area, which you can do here as well, and make the y-axis your bottom function, if you want to do it like that. Now, since that complicates things, we're probably just going to leave this in terms of x. Okay. Now, that's part 2. Part 3, set up the integral that represents the process. Now, our area, okay, what are my 2 points of intersections in terms of x? Negative root 3 and root 3 of my top function, which was my top, what's my top function? 3 minus my bottom function, so minus x squared dx. Now, is there another way I can write this? Now, I'm not talking about left and right. I'm talking about just another way to write this function. Because what kind of function is this? It's an even function. What do we know about even functions?
Yes, so 0.
Yep, we can double from 0 to square root of 3, the same thing. Again, because this is symmetrical, it's an even function, symmetrical, we can just double from 0 to 3, square root of 3, which would be easier, right? Yeah. All right, so for solve the integral, we're going to solve this one over here because it would be easier. So 2 integral from 0 square root of 3 of 3 minus x squared dx gives you 2 times, what, 3x minus 1/3 x cubed from 0 to square root of 3. Which 0 would just give you 0, which is a nice part about it. So all I do is plug in root 3, so 2 times 3 root 3 minus 1/3 of 3 root 3.
How'd you get 3 root 3? Like 1/3 times 3 root 3.
X cubed is, if you cube this cube root sorry, if you cube the square root of 3, you get the square root of 3 times square root of 3 times square root of 3, right? Which is 3 times square root of 3. So we can rewrite this as 9 root 3 over 3 minus 3 root 3 over 3, which gives you 2 times 6 root 3 over 3, which is 12 root 3 over 3. Or what? Yeah, let's just write forward 3.
We're going to just need you 3 times 1/3. And then
So I did. That's where I got the 3 root 3, right? So yeah, 4 or 3. Now it says confirm your result in your calculator, but what's your calculator going to give you? Yeah. So path integral from, well, we can say 2 times the integral. If you type in 4 second root 3, you get the same answer. So yeah. So it does work. All right, so we got some practice problems on here. It does help to draw this out. We have x squared plus 2, y minus x equals 1 and 2. So x equals 1, x equals 2. We have bounds here. All right. Y equals negative x. So we'll go down here. So y equals negative x means at 1 we should have negative 1. At 2 we should have negative 2. That's really terrible. Let's try that again. So we're negative 2. There we go. All right. That would be a hand draw graph. And then we have x squared plus 2. So that means starting at 0 we get 2. At 1 we get 3. And at 2 we get 6. Way up here. We want, I can do this. So we want that area right there. Now the nice thing is, if we're leaving this in terms of x, and you kind of make a note here, if functions are in terms of x, the bounds also be in terms of x. So if this is f of x minus f of x, my bound should be what? What are my x values here? 1 and 2. So I'm bounding this from 1 to 2. That's what's kind of nice about this function. I don't have to find my bounds, they were given to you. All right. What's the top function? X squared plus 2 minus the bottom function, negative x dx.
Can you change that to 12x?
Yes, you can simplify. So if you want to write this as integral from 1 to 2 of x squared plus x plus 2, you can do that. gives you 1/3 x cubed plus 1/2 x squared plus 2x from 1 to 2. 2 gives you 8 cubed plus 2 plus 4. 1 gives you 1/3, let's put that in parentheses, plus 1/2 plus 2. The nice thing is I can simplify this a little bit because I'm going to subtract. 2's are going to cancel. All right. Not much else I can do. So this is going to give me 20 over 3 minus 5/6. So it's going to be 40 over 6 minus 5 over 6, 35 over 6. Try number 2. So find the area from 2 minus x squared and g of x equals x. So nice little x equals x. 2, 1, 2 minus x. So 1, 1, and then. So we do need to know where these intersect. How are we going to find where these intersect? You can, but it's also pretty easy. If we have, when they're equal to each other, so 2 minus x squared is equal to x. So bring these over, x squared plus x minus 2 is equal to 0. Factors to be x minus 2 and x plus 2, x minus 1, which gives you negative 2 and 1. So that's where they intersect.
Well, we can use type.
You could factor. Come on, guys. So we are going to integrate from negative 2 to 1 of what's my upper function? 2 minus x squared, my lower function x dx. So integrate from negative 2 to 1 of negative x squared minus x plus 2 dx. Gives me negative 1/3 x cubed minus 1/2 x squared plus 2x from negative 2 to 1. Now, getting 1 gives you negative 1/3 minus 1/2 plus 2 minus plugging in negative 2 gives you positive 8/3 minus 2 and then minus 4. So this will simplify to negative 5/6 plus 2, so that is 7/6 minus this would be negative 6 plus 8/3, so negative 10/3. So that's going to become 27 over 6.
Yeah.
Which can reduce by 3, right? 9 over 2. Now, for the rest of these, you're going to use a calculator to do the integral. But let's look at this. Find the largest region bound by the graphs of sine and cosine over the interval from 0 to 2. Missing something here. All right.
What's that?
See, I want to change this question. I want to change this question. What I want to do is find the area between the graph of f of x is 3x cubed minus x squared minus 10x, and g of x is negative x squared plus 2x. All right. So let's look at these. Let's look at the graph first. Clear. 3x cubed minus x squared minus 10x. And we have negative x squared plus 2x.
Which interval?
Just where they intersect. So what's the issue here? Yeah, I'm going to have two different integration. Why am I going to have two different intervals integrations? Because on the left side, guys, on the left side, my cubic function is greater than my quadratic function, but on the right side, my quadratic function is greater than cubic. So let's find those intersections. There they are. I like how I can just press intersect and it pops up. That's great. So for the first integral, I'm going to go from negative 2 to 0 of 3x cubed minus x squared minus 10x minus negative x squared plus 2x plus, and on the second one, I'm going to go from 0 to 2 of negative x squared plus 2x minus 3x squared minus x, 3x cubed minus x squared minus 10x dx. So here I'm going to have two separate integrals because the two functions intersect. And when they intersect, one function becomes larger than the other.
This is when they intersect, like,
In between, yeah. When they intersect in between there, yeah. When we have multiple points of intersections, yeah. Not just two. And you can plug this in your calculator. And I'll just let you guys know it is 24 because we just don't have time.
Okay, I just looked at it.
Yeah.
All right, I'll be right back. I didn't know homework, now you can.
or this one, you know,
We are, yes. We need to do one job, yeah. Good morning. We don't know, man. We.
elementary school, I have an extra 5. Easy.
So, yeah, we're gonna do that for sign policy. It's gonna be good. Right, I'll say it.
Yes.
Homework. We got it. Those are the things. We're gonna bet you. $70.